Hi everybody, today I'm going to show you an example of finding the resistance for circuits in parallel. We're going to calculate the equivalent resistance, which will denote our EQ for the circuit below. Once we get our answer, we're going to round it to 2 decimal places. What you should notice is that we have 3 circuits in parallel. To find the equivalent resistance, we can use the formula 1 over R1 plus 1 over R2 plus 1 over R3. That can get a little tricky when you put it in the calculator because you have so many fractions which would require a lot of parentheses, so we can use this trick. Because 1 over x is the same thing as x to the negative 1, we could take what's in the denominator, the 1 over r1 plus 1 over r2 plus 1 over r3, find that, and then take that to the power negative 1. It looks like this. What we're going to find is 1 over r1 plus 1 over r2 plus 1 over r3, then we'll take all of that and put that to the negative 1 to get our equivalent resistance. That means we'll find 1 over 9 plus 1 over 18 plus 1 over 49, get that value, put it to the negative 1, and let's go over to a calculator so I can show you what that looks like. Let's start with just a regular scientific calculator. I'm going to put parentheses, 1 divided by, our first number was 9, plus 1 divided by 18, then plus 1 divided by 49. All of that is a quantity that I want to raise to the negative 1 exponent. I can hit the up arrow and then hit negative 1, or you see there is a key that says x to the negative 1. Let's click that. When I pushed enter, I got a fraction. I can change that back to a decimal by hitting the second and then the FD, that means go back and forth from fraction to decimal. It says it's 5.345. But we said we want our answer with 2 decimal places, so we'll make that 5.35. We could do the same thing in a graphing calculator. Again, I'm going to hit a parenthesis, 1 divided by 9, plus 1 divided by 18, plus 1 divided by 49. Close the parenthesis, negative 1 exponent. There's our 5.35 again. Our final solution says the equivalent resistance is 5.35. Remember to put your units as kiloohms that we got from the original problem.